Well, hi everyone. My name is Jose Liendro. Let me also open my camera so you can see me. Hi, hello everyone. This presentation it's about AWS Glue service. This is a serverless data integration, and well, let's start. First of all, we are this place. It's named like OTT. It's an online tech talk, and it's a place where we are sharing knowledge between us, and it's in a public way where we are sharing some discoveries, research, new frameworks, technology, in a daily basis. So what we have implemented, it's a YouTube channel where we are storing these kind of recordings, and as well we have a blogspot in Medium, where we are posting different types of articles regarding this kind of process. So if you can take a look, and if you like, please give us like, so that will help us to continue with this kind of process. So we will talk about the AWS Glue service. So this presentation will have two parts. The first one will be related to what the service does, the terminology, use cases, how can we use the service, what are different types of use cases that we can cover, transformation, convert semi-structured schema to relational schema, and as well, they will go in deeper regarding the ETL jobs, what they are, and the type of components that they have. We will go through the pricings and versions, some topics regarding the formats of the files that we are using, and as well the stakeholders that can use this type of service. In part 2 of the presentation, we will cover an example use case, where I will be sharing an experience using this service, where we are reviewing what a use of a crawler and how we are populating tables with classifiers, how the schema is inferred by this service, as well as some process to improve the performance using indexes, and how it looks at jobs in an example. So the first of all, AWS described this service in this way. It's a serverless data integration, and the purpose is to move data sets of nearly or any size and prepare them for analytics and machine learning. So the purpose is to process data in a way that it doesn't require to manage infrastructure on our own. So then, so what Glue is a fully managed ETL service. ETL, what it means is like three main steps: extract, transform, and load. That is the pattern that we are using through this service. So what it does is to categorize, clean, enrich, and move data between various data stores, right? So that is the main core of the service proposals. So the name is Glue and has several components that they have components. Let me here. Sorry. So we have multiple components. The main ones we will see through AWS that we were talking about a Glue catalog, that it's the place where we are storing metadata for information. Then we have the ETL engine itself that generates Python or Scala code. And then we have a flexible schedule for dependency resolution and job monitoring and retry mechanisms. So this is within the context on serverless. So no infrastructure, we don't have infrastructure to maintain. And we can convert semi-structured schemas to relational schema on the fly using dynamic frames. So in this example, for example, we are seeing how in this diagram, we have like different components, and the ones that they are represent a glue are the glue trigger, the glue job, and then we have a crawler and a data catalog. Those are the the components that that represents the Glue service itself. So in this use case, what we have is an event that fires a Glue trigger. That what it does is to run a job where we are doing like all this process to transform data in order to put it on an S3 bucket. So the input of this job will be data stored in what we name it as Glue data catalog, where we store metadata for information. And what we have, it's a component named the crawler, that the crawler, what it does is to go for information and put it on our data catalog in order to make some queries, transformations, and managing all these data. Then in this schema, we have another service that we will not cover in here, which is Athena. And with Athena, what we can do is just to, here in this example, is to run SQL queries into an S3 bucket, or we can do as well over to the data catalog, because the process that we are doing through the Glue jobs is to infer the schema of the information that we are doing, that we are building. And then we have a quick site that is a kind of dashboard where we can represent the information in a different way. So here are some historical notes about the service. So this Glue service was started in 2017. Then in 2020, it has official support for Scala and Python. And then last year in 2022, in November, they announced a release of a new job type with the name Ray. Ray, what it does is an open source. It's a framework that enable us to run Python code in a distributed way. And as well, they announced with this within this new engine with a library with the name Wrangler. And the Wrangler, what it does is the equivalent solution for Pandas. If you're familiar with Pandas, it's a library that will help us to manage like data in a way. It's something similar to MATLAB or Octave that we can use to process data. Then regarding the terminology or dictionary, just to put in examples, here, for example, on the left side, we have how it looks, the AWS console. What it has like two main categories, first, the data catalog itself, and then we have the ETL, where we can find the Glue Studio and the jobs that we are building. So this component, we start talking in the previous slide. What we have is the data catalog, where we persist metadata store, where we persist metadata. Then we have classifiers. The classifiers will be in charge to trying to infer and do their best to infer the schema from a given input. Then we have connections to connect with different sources and outputs. Then we have the crawlers that they connect to a data store and then put it on our data catalog. And then we have a data source, a data store to persist. It's a repository to persist storing data. And then we have a data source and a data target regarding a specific transformation. So then when we run a crawler, what we do is to populate metadata and infer schema related to some source that will be translated to a table into the data catalog. So there in a table, what we have is a metadata definition of what we are importing from a given source. So in this diagram, for example, we have a data source. We have a crawler that will take information from a given data source that, for example, could be an S3 bucket. And then we'll store that, it will infer with the classifiers into our data catalog. It will be storing that information in tables. So then what we have is this pipeline where we have our data source that will be represented as tables from the data catalog. Then we have the steps to transform, and finally we will load that results to a data target that could be as well a table into the data catalog. So in this case, we can cover like different scenarios or use cases. First, we can, for example, organize, clean data, validate, format, enrich data in a data warehouse. That is one example. Then we can, in this step, when we are running like a job, we can do all this process, try to clean, to validate, to remove columns, to add aggregations, data, to joins data. One of the main purpose here is to have a central place where we can connect different sources, and in one single place just do all the transformation from within with a mixed type of sourcing. For example, an RDS, an S3 bucket, with different formats. We can handle like multiple formats as CSV or Parquet, and we have a lot of formats there. Then as well, we can import, load data from many different static or streaming data source. That means that, for example, we can go and extract files from an S3 in a static way, let's say. And then as well, we can stream data from sources, like, for example, an IoT device or a log, for example, that's streaming data constantly. Then we can run serverless query against an S3 data lake, because here what the technology here does for us is to infer the schema. So with the schema, we can then run SQL queries, for example, using Athena. Then we have a catalog S3 data, making it available for querying with Athena and Redshift Spectrum. What this tool does for us is to infer the schema, so that allows us to import a given source, infer with the classifier the schema of the information, and then that allows us to run SQL queries, for example, to that given data set. That we can do it with Athena or Redshift Spectrum, that are other services here in AWS. And then as well, we can create event-driven ETL pipelines. For example, that means, let's say that we have an S3 bucket where there's a process where we are dumping data from a database. So once we put a new file in an S3, we can capture that event to fire like a job to run all the transformation and different sources. So we can then connect and make these jobs execute through events. Well, here in general, this is one of the use cases that we can have here with this tool, is to convert semi-structured schema to a relational schema. So here on the left side, we can have like this structure that we don't have. We have a semi-structured schema that we can get from different type of sources, and here each of these nodes could represent a different source of our job. And what we can do during a transformation is to get like a relational schema that we can store in our tables to run the queries. So here we arrived to a Glue ETL job and how it's structured, how are the components. So in this case, the main case is the core is the job itself that runs transformations. And these are, here we have two arrows, the source that the information that took from the data catalog, and as well it could target the output to a different table within the same catalog. This diagram is not complete in terms of this source code comes from different places. For example, it could come from an RDS on an S3 bucket, but this approach has some benefits that we can talk later. For example, once we are importing a table into a data catalog, we can partition the data and we can create index in order to improve the performance of the queries that we want to run. Then on the top right, we have schedules or events that can fire the jobs. And finally, the job, the output of the job, the job will be translated to a script, which is this right component. And they offer different ways to produce this script that could be today could be in PySpark or in Python, as we talked at the beginning. Sorry. One more thing to consider here in this process around the job is that we have a monitor. The monitor, what it does is to monitor and produce and show the metrics to review how the jobs executed, and in case they fail, they have a retry mechanisms. So that's another thing to consider. Then around the type of jobs that we can create, we have some flavors. First of all, we have some output formats that this process can store. They can be JSON, CSV, ORC, Parquet, Avro. There are different type of files that they can produce. And then we have three main types of jobs that we can have. So we have the Spark ETL job, we have the Stream ETL job, and we have the Python shell job. Here we have the two main flavors are Spark, Python, and the Stream ETL job is related to, for example, how to stream data in real time. For example, as we mentioned, with an IoT device. In this particular architectural, where we are retrieving information from a Raspberry Pi with an MQTT protocol through an IoT core, and then we process it in a Kinesis, and then we arrive to a Glue job. We are receiving the streaming of that information. That the output of that stream will be stored in an S3, and then will be consumed by Athena and the crawler to produce the data catalog. Here is a screenshot of the AWS at the time where we are wants to create a job, an AWS job, where we can choose like this type of flavors. The first one is related to a visual mode, where we can create queries in a visual mode. It seems like Databricks. And then we can create a visual mode from a canvas. Here we can set the source, the target of the output of the job. We have the Spark script editor. We can write Python shell, and we can write Python in a shell. We can use Jupyter Notebook, and here is one of the new features that it's to enable the Ray engine into the job. This is just a note regarding PySpark, just to define what it is. PySpark is a Python API for Apache Spark. It's an open source distributed computing framework and set of libraries for real-time large-scale data processing. If you are familiar with Python and libraries such as Panda, then PySpark is a good language to learn to create more scalable analysis and pipelines. So I think this is important related to what the purpose of this tool in general. because one of the main benefits to use Glue is to create a type of job that could be distributed. So behind the scenes, we have Spark, and we are using Spark through PySpark, which is a Python API to use Spark that behind the scene as well use Scala in order to scale and to scale and split the work that we want to do given a transformation. So in this case, we have, for example, on the left side, we are seeing how this visual mode works, and we have 3 layers. On the left side, we have a data source. In this case, we have connected to a MySQL database, and here we are consuming from an S3 bucket. In the middle, we are doing transformation, applying some mapping transformation, and then join the result from those sources and produce an output on an S3 bucket. That is how it looks, the visual mode. So once we create this configuration, then we automatically have the equivalent code in PySpark to run the job. Then to consider and around this topic to distribute the work, when we are configuring a job, and specifically talking about Spark, we have different types of workers that we can use to process some data. And here we have the main one are G1 and G2, and they at the end are machines that has a different type of configuration. For example, the G1 has 2 cores and 60 GB of memory and 64 GB of disk. Of course, each of these workers will have different cost, but will depend on the type of work that we want to do. Is the ones we need to choose or to explore in order to get a result faster than later. These are related to Spark. And regarding Ray, we have a different type of worker with this name, sets2, that will have as well more power than the workers that we can use for Spark. Then, just as a note, we have different type of triggers in the way that we can execute or call or jobs. That can be, for example, this glue trigger, and if we remember one of the last slide, we have as well that we can schedule a job or we can fire it from an event. And then we have the monitoring layer in order to review how a job was executed. So that is in general what we have here. Then just some notes regarding the current version and pricing. Right now, today we have the latest version is 4.0 from Glue, and this is the cost regarding to execute a crawler or a job, and it's related to a unit named DPU, and it represents a unit of work in the worker that we choose, the ones we referenced before. So currently we were using the version 3.0 because it's the one that offers us the features to use the visual mode, and 4.0 doesn't have that feature. And then around the type of formats that we will use during these pipelines. Here it's some comparison between the CSV and the Parquet files. So here, and I found this interesting because this is the format of a file, right? So in this table, we are comparing like the same data in different formats. So in this first row, we have a CSV file that has 1 terabyte, and then it will require a runtime of 200 seconds, and then it will scan like a terabyte of data, and it will have a cost of $5. So within the same content, but with a different format, like Parquet, will have, it will represent like 100 of gigabytes. It will reduce to just 6 seconds to run a query. And the data scan will be just 2 gigabytes, and the cost will be reduced to some sense of to this value. So it represents like 80% less when using Parquet regarding the storage that we will need to have on S3. It is like 30 times more faster than to use than CSV files, and as well we have less that data to be scanned. One of the main features of these formats is like the Parquet files, what they are column oriented instead of row oriented at the CSV. So that, for example, allow us to choose just the columns. If we are doing a query, we can just select the columns that we want to use, and that will reduce the execution time. It will reduce the storage that we need to have for that information. So I think it's something to consider, at least when we are where we are producing at least the output, and as well to request the inputs to be in some of these formats. And then finally, this is an architect solution regarding how this ecosystem could be. And I found it interesting because they have like different types of roles in a company. So for example, we didn't mention that there are as well another service named Data Brew that is specific to clean and normalize data. And here we have, for example, a data analyst. Then when we are running and doing our translation here in a Glue ETL, we have a data engineer, and this step will produce an output of a given output in a data lake or in a data catalog, and then finally we can run SQL queries with Athena, or we can create dashboards with QuickSight, and here we have an analyst or a business user. So within these service and solutions, we can cover like different places and perspectives given some needs. So well, so looks like here we will expose some. I think some of these slides move, so it's a little surprise to me. Okay, just there are some missing slide, so I will just talk about what we did. We received a request because we want to produce one of these. We want to produce a job that took information from an S3 bucket, and then create some queries and produce an output. So the main request here is to include and to create those queries in a way that use all the power from Glue. That means that we want to do is to use Spark in a way that we can distribute the work to be done in different workers. So we did some discovery and some experience with the service. First of all, we used the crawler. We used the crawler that it has this definition. So here we need to we put it a name, and we put a data source. In this case, with an S3 bucket. Then we will need to enable or give an IAM role that have access, in this case, for this particular source. In this case, S3. And then we define the way that an output will be created and how it will be produced. In this case, we are pointing to a database in our data catalog. Then once we have the tables remember when we are running a crawler, we have classifiers then, and they have a pretty extensive list of classifiers, and they are prioritized, and they trying to do their best to infer the data schema. And here we don't need to define anything. They just infer what it is the format of the source. And once we have in this example, we are seeing the schema of a table where we have all the fields, the columns, and the type of each of those files. And I found interesting that we can create partitions of this data, and I think it's aligned to the way to distribute the work. So, for example, in this query, we want to create these two partitions over these two fields. So that allows us to create indexes over those fields, and as well, it will create a process where the storage will be organized during this partition, and I think this, and I guess that way allow us to be more efficient at the moment to run the queries, because we are going through that month in particular, or some months in particular, or some fields in particular. So the partition are related to the way that we are storing information. And then once we have the partitions, we can create indexes over those fields, and this process could be done by one index or multiple in a common way that we can do in a Postgres or MySQL database. And once we have that data, we create a job, in this case, using an interface where we can create this diagram. Each of these components is named as a node, and we can categorize each of these nodes as a source. As a source, we can have an action that could be the ones that we saw previously, like a mapping, filter, union, and so on. We have a target, and then we have other tools to remove or undo. So here, for example, we are in a node that what it's doing is a transformation, and the transformation will be a union of different sources. Something good here to mention is that we have a version control where we can link a repository in order to store the result of the queries that we are doing. And here on the right, we have a data preview where we can review the result, the partial result of the query that we are doing, that will use a DPU. So it will create a worker, and the work it's a little bit slowly, but will run the query that we want to, and the transformation, because we will create a worker, and the worker, it will fire all the pipeline to get this example to us. Here we have a tab, and this is within the Visual Studio that has the jobs. And here we have the job details, where we can define the way, where are the technology that will be involved to that particular job. And in special here, we can assign the type of worker that we will use, for example, the G1, and the number of workers that we want to use. If we as well, there is another option. It's the standard option that we can use a different approach to say something like at most use certain amount of DPUs, for example. That is another option. So that is the way that we can set the number of workers to be used in a query. And if you remember, in one of the previous screens, we saw that here we created in the here this diagram to build a query. So this the tool, what it does is to automatically convert the query to PySpark code. So this is Python code that use the PySpark, which is an API to use Spark. So this code, what it does is the output of the process of the job, and the code that will extract, transform, and load data. Finally, the job itself. One interesting thing here is this one. In this diagram, what in the way that we are creating like the queries, we need to create queries like in an atomic way. So every time that we are joining union or doing a merge of the information, we need to do it in an isolated way. And the join itself will be a node here in this process. So as well, I think this way to create and split the query allow us to then, when this code runs, is to be distributed through all the workers. And well, this is the code, the output code. And this is like an initial point to us to start working. And then we can edit the script and customize in a way that we want to do something more custom. But the counter side of this is that we cannot revert the process. Once we arrive to custom code, we then just continue using Spark code. So we cannot go back to the visual mode. So we can then clone the job, for example, to keep it in a visual mode, and then use another one to customize, for example. And this is the view, how the monitoring looks. Once we run a job, we'll have here the like a dashboard to review the metrics. So this was the presentation about the service and the experience that I have during these days. And as well, I know that it was a lot of information and time. Let me know, do we have any question or comments?
Yes. Hello. Can I ask some questions? I believe it's just one question, one main question. You said about this job preference and how you set the CPU, this amount of CPU. In the past, we had some problems with lambdas when we had some lambdas with more than 8 gigabytes of RAM. So do you have a preference to this kind of configuration? Do you prefer less CPUs in the jobs or something like that?
Well, in this case, this presentation was to show what we can do with this service and the experience that we did. So we don't have like a preference, let's say. I think it will depend on each scenario, what we and do some try and error to review to take some results and see if we need to change the way we are doing the query, or to has more workers with less power. I think that will be craft steps to analyze what is more convenient. So in total, I'm not an expert, so I could not give you like an advice there.
Okay, thank you. Nice presentation. Congrats for the presentation. A lot of good stuff. I was talking to Nacho about a lot of stuff in your presentation, so we're going to use a lot of the concepts that you just present. Thank you for that.
I have a couple of questions, Jose. Perhaps you can answer. It has to do perhaps with the classifiers or catalog that I was not very clear on the difference. We have a stream of JSON files with 3 or 4 different formats, right? And they might be related, they might share IDs, or they might share some other concepts among these files, because these JSON files are reports that are talking about certain assets, different reports explaining different things. Does Glue identify kind of the, call it, relational structure of these inputs?
No. In this case, that kind of work will be done in the job itself to connect those sources, let's say. So the first step there will be to import those different JSON files and review if the schema is correct or not, if you need to do any kind of transformation. and then you explicitly do the merge of those queries. You are joining those.
It's one schema per file
Right.
type.
Right. We will have, once we have a source and classifier, what it does is to infer the schema. And then as well, it could be created a custom classifier, but the output of that process will be a table, and the table will have a metadata. So each source will have different metadata. Okay, then you can use join.
Talking about one source, the JSON file that we are getting, it's not columnar. It has arrays of things. Is it smart enough to understand that there is one table with a one-to-many relationship with another table? It creates a schema, or it is just one plain table? Like, let me put it this way: the JSON file has the information of a song and multiple authors of the song, right? Multiple writers of the song. Do you know if it creates the table song and the table author and does a one-to-many relationship? Because multiple songs can share the same authors. It's actually a many-to-many. Is it smart enough to detect that use case?
I didn't do that test. What the one and I didn't cover the use case, but in the presentation we showed, we saw that is one of the use case of the tool, to get like a semi-structured schema and produce like a relational schema. I didn't do experience, but seems like it's doable. And I don't know how it works in case you are, what I understand, given all the research, is like that source will be flattened in a single table in a relational way. So I guess that will be a kind of merge, a merge of kind of, it will look like a merge, I guess.
Okay.
So in case you want to split that source into different tables, then you can use the job to do that work for you.
Interesting. And the last thing, the output of Glue. Can it go? I mean, can it basically output information into Redshift or some other data warehouse that then I can use to query? Because making queries on top of flattened text files, even if Parquet, is much more expensive than using a data warehouse.
Yes, they are they have a very long list of connectors, and they can put data and take that data from a Redshift, for example.
Excellent. And this is a long shot. By any chance, do you know if we can present any of these configuration tools to an end user into some sort of embedded web application or something like that, so we don't give them access to AWS, or so we can put these kind of configurations and data manipulations as part of a user interface, an end user?
No, I think in the diagram, what I can infer is like we have not from an ETL perspective. I don't know, maybe from AWS you can create some roles to just give access to the AWS Glue Studio. But what I understood here is that the ETL will produce an output. The output then can be consumed from different places. For example, QuickSight or Athena. So in that way, I think you can split the type of stakeholders that will consume the data.
Beautiful, thank you.
Sure. Well, guys, so thank you. So see you next time. Bye-bye.
Thank you. Bye-bye. See you.
Bye. Thank you.
Bye-bye.
See you.